Imagine a star the size of a small city, 20 kilometers in diameter. But this star weighs more than our sun. And it has a magnetic field so powerful that it is able to tear apart atoms at a distance of thousands of kilometers. This is a magnetar, the most dangerous object in the known universe. Magnetars are a type of neutron star. When a massive star explodes as a supernova, its core collapses. Protons and electrons are compressed so much that they combine into neutrons. It turns out to be an object of incredible density. 1 teaspoon of neutron star matter weighs 1 billion tons. It's as if you took all of humanity, all the people on the planet, and compressed them into the volume of a sugar cube. But magnetars are special neutron stars. They have a magnetic field 1,000 trillion times stronger than the Earth's. This number is difficult to even comprehend. The Earth's magnetic field is about half a Gauss. The magnetic field of an ordinary refrigeration magnet is 100 Gauss. The magnetic field of the MRI machine in the hospital is 30,000 Gauss. And the magnetic field of the magnetar reaches 1 quadrillion Gauss. 1 with 15 zeros. At such values, magnetism ceases to be just a force of attraction. It is becoming a weapon of mass destruction at the cosmic level. The magnetar's magnetic field is so strong that it distorts the atoms themselves. The electron clouds around the nuclei of atoms are stretched into needle-like shapes. Chemical bonds are broken. Matter ceases to exist in its usual form. If the magnetar were at a distance of about 380,000 kilometers from the Earth, the consequences would be catastrophic. All electronic devices on the planet would fail instantly. Every hard drive, every flash drive, every bank card would be completely erased. The information would disappear forever. But that would be the least of the problems. The magnetic field would begin to interact with the iron in the blood of every living thing on Earth. Human blood contains iron and hemoglobin. This iron is bound to proteins and is not ferromagnetic under normal conditions. But the magnetic field of a magnetar is not ordinary. It is able to affect even diamagnetic materials, which are usually repelled by magnets. With such an effect, the iron in the blood would begin to move. Erythrocytes would burst. Blood vessels would be damaged from the inside. Every person on Earth would experience internal bleeding at the same time. Death would have occurred within minutes. But even this is not the whole picture. The planet's atmosphere would begin to tear apart. Oxygen and nitrogen molecules, although not magnetic in the usual sense, would be affected at the quantum level. The air would begin to glow from ionization. A magnetic field would induce electric currents in the Earth's crust. The planet would be warming. The oceans would boil. The entire biosphere would have been destroyed in a matter of hours. Fortunately, the nearest known magnetar is about 9,000 light-years away. That's far enough away that we're safe from the direct effects of its magnetic field. But even at this distance, magnetars pose a different kind of threat. Magnetars are unstable. Their magnetic field is so powerful that it creates tension in the star's crust. Imagine that the entire star is under tremendous pressure. The crust of a neutron star is hard, 1,000,000 times stronger than steel. But even she can't stand it. Starquakes occur periodically. The bark cracks. And then there is a release of energy. Such emissions are called magnetar flares. In a fraction of a second, a magnetar can release as much energy as the sun radiates in 100,000 years. This energy is emitted in the form of gamma rays and X-rays. A directed beam of deadly radiation pierces space at the speed of light. On December 27, 2004, an event occurred that astronomers call the most powerful flare ever recorded from outside the solar system. Magnetar Sgr. 1806-20, located 50,000 light-years away, experienced a massive starquake. A wave of gamma radiation reached the Earth. In a fraction of a second, this pulse ionized the upper layers of the Earth's atmosphere. Several satellites temporarily failed. Radio communication was disrupted. And this is despite the fact that the source was located on the other side of the galaxy. If such a flare occurred a few tens of light-years away, the consequences would be catastrophic. The ozone layer would have been destroyed. Life on the surface of the planet would be exposed to a lethal dose of radiation. Scientists believe that such events could have led to mass extinctions in Earth's past. The Ordovician extinction, which occurred 450 million years ago, wiped out 85% of marine species. One theory links this event to a burst of gamma-ray radiation from a collapsing star or magnetar. The ozone layer was destroyed. Ultraviolet radiation from the sun reached the surface of the ocean. Phytoplankton died. Food chains collapsed. Now imagine what happens to the person who happens next to the magnetar. Of course, this is a purely theoretical scenario. No spacecraft can approach such an object. But let's follow second by second. At a distance of 1,000 kilometers from the magnetar, you are still technically alive. But your body is already starting to react. The magnetic field here is about 1 billion Gauss. That's 10,000 times stronger than the most powerful IMERT scanner on Earth. Electronic devices stop working. Any electronics instantly fail. Your spacesuit, if it depends on electronic systems, is now just a shell. But the main thing begins at the atomic level. The atoms in your body begin to deform. Electrons move in orbits around nuclei. The magnetic field affects these orbits. At weak fields, the effect is imperceptible. But here the field is so strong that the electron clouds are stretched out into elongated ellipses. Atoms cease to be spherical. They become needle-like. This changes the chemical properties of the substance. The bonds between the carbon, hydrogen, oxygen, and nitrogen atoms that make up your body begin to weaken. Proteins lose their structure. Enzymes stop working. The DNA begins to disintegrate. Your body at the molecular level ceases to be functional. At a distance of 500 kilometers, the situation is deteriorating. The magnetic field here is about 10 billion Gauss. The water in your body becomes a diamagnet that responds to a magnetic field. Water molecules begin to orient themselves along the lines of force. This creates internal tension. The cells begin to rupture. Blood vessels burst. Internal organs are destroyed. The iron in your blood now actively interacts with the field. Erythrocytes are literally torn apart. Hemoglobin breaks down. The blood stops carrying oxygen. But you are no longer breathing. Your lungs are damaged. The heart does not beat. The nervous system is turned off. You are dead, but your body continues to disintegrate. At a distance of 100 kilometers, the magnetic field reaches 100 billion Gauss. This is where a quantum effect called vacuum birefringence occurs. Empty space begins to behave like crystal. Light travels differently depending on the polarization. The vacuum ceases to be empty. Virtual particles that constantly appear and disappear in quantum foam begin to interact with the magnetic field. For your body, this means total annihilation at the atomic level. The nuclei of atoms begin to deform. Protons and neutrons are held together by the strong nuclear force. But even it begins to be distorted under the influence of such magnetism. Atoms of iron, calcium, and carbon disintegrate. Your body turns into a cloud of elementary particles. At a distance of 10 kilometers, you enter a zone where the magnetic field exceeds 1 trillion Gauss. Here space and time are distorted. The magnetic field is so strong that it creates a gravitational effect. It sounds strange, but according to general relativity, any form of energy bends space, time. And magnetic energy in such quantities creates a noticeable curvature. On the surface of the magnetar, just 10 kilometers from the center, the magnetic field reaches 1 quadrillion Gauss. This is the limit of what can exist in our universe under the known laws of physics. Here, matter exists in a state that we cannot reproduce in any laboratory on Earth. The crust of a magnetar consists of a crystal lattice of iron nuclei immersed in a sea of electrons. The density here is 1,000,000 tons per cubic centimeter. Under the crust there is a layer of superfluid neutrons. Even deeper in the nucleus, there may be quark matter. Protons and neutrons decay into their constituent quarks. This state of matter existed only in the first microseconds after the Big Bang. Magnetars rotate. Most of them make one rotation every 5-12 seconds. This may seem slow, but for an object of this mass and density, it's an incredible speed. The magnetar's equator moves at a speed of thousands of kilometers per second. This creates additional stresses in the crust. When the crust cracks, the energy stored in the magnetic field is released. Magnetic field lines are broken and reconnected. It's similar to solar flares, but billions of times more powerful. Plasma accelerates to speeds close to the speed of light. Streams of gamma rays and X-ray photons are emitted. These flares can be observed from Earth. Astronomers use space telescopes capable of detecting high-energy radiation. In recent decades, about 30 magnetars have been discovered in our galaxy and nearby galaxies. There are probably more of them, but many remain invisible because their radiation is not directed in our direction. Magnetars do not live long by cosmic standards. Their powerful magnetic field is slowly dissipating. The process takes about 10,000 years. This is a blink of an eye compared to the age of ordinary stars. Gradually, the magnetic field weakens. Outbreaks become less frequent. Eventually, the magnetar turns into a normal neutron star, still dense and massive, but less active. But as long as the magnetar is active, it remains one of the most dangerous objects in the universe. Its magnetic field can tear apart any spacecraft at a distance of thousands of kilometers. Its flares are capable of destroying life on a planet tens of light years away. This is a cosmic eraser capable of erasing not only information from magnetic cards, but also life itself. The existence of magnetars reminds us of how fragile our civilization is. We live on a small planet protected by a thin layer of atmosphere and a weak magnetic field. Around us, space is full of objects of incredible power and danger. Black holes, neutron stars, magnetars, supernova explosions, gamma-ray bursts. At any moment, a beam of deadly radiation can pierce the solar system. We will not see it approaching. It moves at the speed of light. When we notice the outbreak, it will be too late. The radiation will already reach us. The ozone layer will be destroyed. Life on the surface will be threatened. Fortunately, the probability of such an event is extremely small. A statistically powerful magnetar burst or gamma-ray burst threatens the Earth about once every few 100 million years. This is rare by human standards. But on a geological scale, this happens regularly. And this may explain some of the mass extinctions in the past. The study of magnetars is important not only for understanding exotic physics. It also helps us assess the risks to our planet. Astronomers make maps of known magnetars, track their activity, and try to predict flares. So far, we cannot protect ourselves from such a threat. But knowledge is the first step. Magnetars also open a window into extreme physics. In laboratories, we can create magnetic fields of no more than a few million Gauss, and then only for a fraction of a second. When we study magnetars, we see what happens when fields are billions of times stronger. This makes it possible to test the theories of quantum electrodynamics, general relativity, and nuclear physics in conditions unattainable on Earth. Some physicists have speculated that magnetars may be the source of fast radio bursts, mysterious signals that astronomers detect from distant galaxies. These bursts last milliseconds, but release as much energy as the sun radiates in years. Their nature is still not clear. But magnetar flashes fit the description. There is even a hypothesis that magnetars can create exotic particles, such as axions or magnetic monopoles, which are theoretically predicted but have never been observed. If these particles exist, magnetars, with their extreme conditions, may be the only place in the universe where they are produced in appreciable quantities. What if we could harness the energy of a magnetar? Theoretically, a single burst of a magnetar contains enough energy to power the entire human civilization for millions of years. But this is practically impossible. We can't get close to the magnetar. We don't have materials that can withstand such magnetic fields. And we don't know how to store or transmit such energy safely. Magnetars will remain an object of study from afar for a very long time. But every sighting, every outbreak recorded, adds a piece to the bigger picture. We learn more about the behavior of matter in extreme conditions, about how neutron stars form and evolve, about what dangers lurk in the depths of space. In a sense, magnetars are a reminder of the power of nature. Humanity is proud of its technology. We split the atom, launch satellites, explore other planets. But a magnetar is an object before which all our power is insignificant. It's a city-sized star that contains more energy than our entire civilization has used in history. And this energy is contained in a magnetic field capable of tearing matter apart at a distance. Magnetars exist somewhere in the depths of the galaxy. They spin in the dark, accumulate tension, and from time to time spew streams of deadly radiation. Most of them we will never see. But they are there. And they remind us that space is not an empty, safe space. It is a place full of wonders and horrors, beauty and danger. And somewhere, perhaps, right now there is a magnetar flash. A beam of gamma radiation pierces space. It moves at the speed of light. In thousands of years, it will reach some planet. Maybe there will be life. Maybe there will be civilization there. And in an instant, everything will change. The sky will burst into flames. The atmosphere will light up. And life that has evolved for billions of years will be erased in seconds. Magnetars are cosmic erasers. They erase information. They erase matter. They erase life. And we can only hope that their beam will never be directed at us.